coming. Keeping it with a customer-centric theme in this room, we're very lucky today to have Dean Abbott, the co-founder and chief data scientist at SmarterHQ, President of Abbott Analytics. He's also the author of Applied Predictive Analytics from Wiley Publishing. Please welcome Dean.
I'm not going to be tethered to the podium. I'm a wanderer. So, one of the things that's interesting to me is I've been at SmarterHQ officially for the last year and a half full time. I was an independent consultant for 15 years doing data mining. I go back a ways. I was talking to the deep learning, Richard, who did the deep learning talk about neural networks. So I remember doing neural networks in the early 90s, late 80s, early 90s. And a lot of what's going on today in data analysis, what's now called data science, what was prior called predictive analytics or data mining, before that pattern recognition, before that cybernetics. It's history is reliving itself. The early 90s were full of what we now call MapReduce, and it used to be called processing with special processors like SIMD computers. We used to use neural networks to process data, single instruction, multiple data to go wide and parallel. But the thing that's most exciting about the field now is that, it's the end of the day. I know your brains are full, and so this isn't as full as it was earlier today, but seeing so many people here interested in being a geek. This is just really cool stuff, because back in the day, there were just a few of us in the back room doing things that nobody cared about. So this is great stuff. Okay, I'm going to define some terms. Talk about big data. You guys know all about big data, so I'm not going to go deep into that. But I'm going to talk about some of the problems that big data brings to the algorithms that we know and love to do machine learning and predictive analytics, and then related to a particular application that SmarterHQ does. My company now, SmarterHQ, does behavioral marketing or software as a service. So we're pulling data in from multiple touch points, the so-called omni-channel experience that customers have with the brand. And so this is the usual big data slide. So the only thing I'm going to say about this, because you all know about the big data, the 3 Bs, or now they talk about the 4 Bs. I am going to complain about that 4th B, because the whole thing in the bottom right corner that X'd out is just a veracity. There is nothing different about veracity than we've always dealt with data. The first 3 Bs really are different now compared to 10 years ago, 15 years ago. The amount of data that's collected, the volume, variety, all that is growing more and more and more, but we always care about how good the data is. Second, customer intelligence. The term customer intelligence is not new. This definition is from Wikipedia. There are books from 10, 15 years ago that use the customer intelligence label. But we're really thinking about customer-centric decisioning. Customer-centric decisioning. Now, fortunately, Jim teed it up for me, so I don't have to go through all the customer relationship management stuff, the order management system data with the headers and the line data and all that kind of stuff. So I won't bore you with those details. So now we want to bring these two together. What does big data and customer intelligence have to do with each other? And this kind of view of the landscape. So we have website data, mobile app, mobile web data, behavioral data that we're collecting, visit level data, which is the great thing about online data, right? We don't just get when somebody purchases something. So in the store, the transactional data on the right side, which you can barely see if I write it down, in store, typically, before beaconing and all the other new stuff that's happening now, it's just a purchase transaction. Very low level of information. But on the web, we see what people click through, we see how long they're on site, we know something more about what their intent is. And that's key when we're trying to make data-driven decisions about what they might do next. So along with that, we get things like demographics, which we can apply. I'm going to talk about demographics in a moment. And we're going to also have, contact, different channels and geodata. Here's the thing, and I'm going fast. I'm going to speak at 1.3x because I only have a half an hour. So intent beats demographics. I love that quote. I get the link to Avinash's post on this subject. What does he mean by intent beats demographics, and psychographics. If we're trying to measure customer behavior, if we're trying to predict customer behavior, and the key is behavior, what is the best thing to predict what something will do? Obviously, it's what they did. So all the stuff we see on TV from the financial services companies that say past performance is not indicative of future behavior and all that kind of stuff is wrong. If it wasn't true, we would all be out of business. We always assume past behavior is going to be somehow predictive of at least near-term future behavior. So it's behavior, predictive behavior. Demographics and psychographics are great if you don't have behavioral information. So for example, Dean going to Dick's Sporting Goods, shopping for size small women's tank tops. Now, you would probably not guess that a 52-year-old man would be looking for women's small tank tops. But of course, I was shopping for my daughter. Now, if you knew the ages of my children, you might guess that. But if you didn't have that information, what is the most important piece of information? It's that I was shopping for those tank tops, right? The fact that I was looking for those, for whatever reason, as a gift for myself, that somehow I was spending into a small woman's tank top, whatever, we're not going to judge. We're just going to say that the behavior is what we're most interested in to try to predict future behavior. So game changer number one for retail is we have more and better data. We have digital data, we have the mobile web data, we have mobile app data, we have website data, we have in-store data. All these different sources of behavior is changing the way we think about how to interact with our customers. Now, the big data piece is interesting. Now, Terrence Howe, IQ of 230, he is really, really smart. He is a big brain, okay? And that really matters. So that big IQ is very important. Let me go back. Big data isn't smart. Big data is just big. The fact that we're collecting a lot of data is great, but it doesn't do what we want it to do, which is reveal the patterns most predictive of future behavior. Therefore, what we need is more than just the big data. What we need is what I'm describing as three-legged stool. We need domain expertise. We need to know something about the problem we're trying to solve. When I watched a video of a Strata conference a couple years ago in San Francisco, and it was an Oxford-style debate on who should your first hire be. Some of you may have been in that debate. Who should your first hire be? A domain expert or a data scientist? Right now it's Strata, so you know how that debate ended. But here's the question: who should it be? And some of the examples raised were things like the Netflix Prize or Kaggle competitions. You don't need to be an expert to win a Kaggle competition, right? Why is that? It's because they did the hard part for you. They defined the problem. They built the data. They defined the metrics you're going to use to judge what model is the best. All you have to do to win the Kaggle competition is the funnest part of the whole problem, right? Build the models. Now that's really cool, but that's not the hardest part. The hardest part is defining what you're trying to build. We need the domain experts. We need the data, the big data, and we need the geeks. We need us to try to build those models, to make sense of all that data, because there's too much data, too many columns like Jim was talking about, making really, really, really wide data with all these different measures. There's too much of it for people, for those domain experts to figure out. We need another way to sift through all that data to tell the story. So therefore, we need to define a unit of analysis. What does a record represent? From a business standpoint, that's the level you're making the decision. So at SmarterHQ, we often make decisions about customers or leads on the day basis. What do they look like today? What should we do with them tomorrow or the next week? Okay? So it's a customer day level of aggregation. Now we could model it a lot of different ways. We could just model at the customer level. And we could say, this is the state of the customer that we care about, and collapse all the history into the record. Or like I described, we could model at the customer day level, where this description is what they look like today. We have what they looked like yesterday, what they looked like the day before. You get the question at the end, Jim, of how you represent all that time history, we tend to represent it completely. We have every customer, every day, every touch point in the data that we can access. CAG competitions. I read this set of insights from a CAG competition or a blog, and I was fascinated by this part of the description. How do you win CAG competitions? Okay, so you use deep learning networks, or you build ensembles like random forests or stochastic gradient boosted trees. Yes, yes. But what else do? You build features. And a moment ago I said the raw data is big, it's important, but algorithms don't always find what's staring them in the face with all the data, the raw data you're collecting. It's almost always better to build some features into the data for two reasons. One reason is sometimes it's difficult for algorithms to figure it out, especially things like ratios. Ratios are difficult for machine algorithms to figure out. Addition is easy. Multiplication can be easy for a lot of algorithms. Division is not so easy. If you remember back to the day Taylor series expansions and things like that, A over B takes a long time to converge. It's a more difficult problem to solve. So that's an important part of this. The other reason is a record is the level of aggregation an algorithm cares about. So think about what a tree does or a neural network does. It's looking within a record and trying to associate fields with the target variable. It doesn't know, it's assuming independence for every record, even if they're really tied to prior history. For that history to be represented in the record, you've got to build a feature to bring all that data into that record. Build features that represent the entire state of that unit of analysis you're looking at. So game changer number 2, the more domain experience with data, the more you are familiar with your domain, the better your data will be. The better your data definition will be, the better your features will be, the better your models will be. Okay, how are we doing in time?
You're doing fine.
Okay.
Yeah.
What are some of the problems we have with big data? Historically, and being someone who's been around for a few decades, being historic meant we take data out of the database or whatever the environment was, load it up, build your model, and you'd run out of RAM if the data was too big, and you'd have to say, okay, how am I going to handle this? Let me sample down, make it smaller so it fits in RAM. And I usually use the overnight rule. If I'm building a neural network or something, if it doesn't finish overnight, that's too long before I can get that feedback. So that's the way we always used to have to deal with the big data we had available to us. Or too many variables. It's too wide. You don't want, even now, you probably don't want to throw 1,000 variables into that logistic regression model, probably. You probably don't want to throw the 1,000, 2,000 variables into stepwise linear regression. Probably not. So we used to try to whittle it down into a smaller subset to make it actionable, often using things like single variable at a time variable selection. A surrogate rule or a surrogate way to decide which variables to include in the model. Or then there are interaction effects. You're building a logistic regression model, or even something like a neural network, or even a decision tree, and interactions can help the final model. Even the reason why I mentioned even decision trees, remember decision trees are greedy searchers. Decision trees, you've got to find a good split first before it splits them to the next level, right? If it gets on the wrong path, it's done. It's like what happened to you right now. If you'd known when this talk started where it was going to go, you may not have stayed, right? But it's too late. You've already made the decision. So decision trees are like that too. They're greedy. They've got to keep on going, and they never go back to where they started. So sometimes interactions are helpful even for trees. Or sometimes you get categorical variables that just have too many levels, like zip code. You've got to do something with that data. Cloud computing for the rest. That has been a game changer for retail and other industries. And this is just a growth chart of on-premises computing versus cloud computing. We saw at the beginning of today the Gartner hype cycle. The 2014 hype cycle showed all the different technologies on that. This is just the cloud computing hype cycle. And you can see that cloud computing, 2014 is here, and it's starting to emerge from the trough of disillusionment into the plateau of productivity. it is getting there. The cloud environments are starting to get to the point where mainstream organizations can use them effectively. Of course, you know what that usually means. What is it like in fashion? As soon as it becomes popular, then it's passé, right? So maybe what's going to be next for us, I don't know what that's going to be. But we'll just enjoy the platform products for now. And then you've got your usual players in the space. So game changer number 3, we can process data better in the cloud environment in a more cost-effective way than we ever could before. So what's happening in retail now, my industry now, is bigger data. We're collecting more data faster. We're learning more about what works based upon our domain expertise and applying predictive models, and we can compute in a cost-effective way in the cloud. So 3 or 4 years ago, SmarterHQ was one of the only games in town if you wanted to do predictive analytics. If you looked at the branding of SaaS solutions with predictive analytics, we're like the only game in town 3 or 4 years ago. If you look today, SaaS solutions for retail, they're littered with predictive analytics, machine learning. They get it, which is, I guess, bad for me, but good for the industry, because the more they're starting to do data-driven decisioning, the more productive the higher ROI. What's not a game changer? The algorithms are not the game changer. I was fascinated this morning with that. There's one quote from one of the talks this morning. It says, look what the organizations are doing. They're buying data and they're open sourcing algorithms. The math isn't the secret sauce, it's the data. That's why I used to tell insurance companies, the best data is not the insurance data, it's the reinsurer's data. Because they've got all the insurance data to try to sort it out. The more data, the more understanding of the domain you have. Okay, so let me go to one example in retail. How much time do I have?
11 minutes.
Okay, excellent. Here's Fred. Fred's shopping in one of the stores that's, let's say, one of our brands, like SmarterHQ, one of our brands is $80. Let's say he goes to these 2 stores. One store is close to his home, one store is close to work. So we're collecting behavioral data about what he does in the store. And that's purchase transactions. But he's also on his iOS device, browsing in the mobile app. And he also goes to the web when he's at home or at work. And shopping while he's there. During his breaks, of course, not during normal business hours. So there are all these ways he interacts with the brand. Historically, what would happen? You would be the digital commerce guy or digital commerce woman, and you're doing all your analytics and stuff. And you're looking at the website, you're saying, you know what? This guy, out of nowhere, he is starting to be a rock star customer. Look at this. He just bought 10 shirts online, different sizes. It was very cool. We're the winner. What really happened, though, is he bought those 10 shirts online. He returned 9 of them in the second store. That second store is getting dinged for 9 returns, and the digital side, they're rock stars. They're getting bonuses, right? So what do we want? What do we really want to know? What we really want to know is integrated, all this stuff together, what's happening. So we want to know at the store level, how engaged is he? How profitable is he? We want to know on each of these different channels, but especially at the brand level, we want to integrate. So we can look at each of these levels of interaction and measure how engaged is he in store number 1? How engaged is he in store number 2? How engaged is he on his mobile app? How engaged is he on the web? Are these going up or going down? Because maybe it looks like he's falling off in store number 1, disengaging, which would trigger what? A coupon or something to try to re-engage him. But if you look at the brand level, you'd say he's not disengaging for the brand at all. He's changing his mode of shopping. So we just want to see all channels in order to get the message about who Fred is and what he's doing. So that means there are lots of things, lots of goals we have that we're trying to measure. Now, in the who part, and I'm glad you put the who, what, why, before, so I don't have to go through that so much. But on the who side, who they are, I color-coded different kinds of models or measures or metrics we would build to describe who Fred is. So is he a high-value customer, a low-value customer, with average order value? Is he he a valued customer, only buying things on sale? These are all descriptions of his historic behavior. Or when we build models to look at his in-store or online activity, is he highly engaged? Does he have low engagement? All these different measures about who he is. Also, what things does he interact with? And then, what are we going to do about that? So from a predictive modeling perspective, I'm putting crisp VM labels on top of this, and we want to know business objectives, what we're trying to understand. And then the data we have can tell us from the models, these different descriptions, we can do the data prep to build KPIs or features that describe different kinds of behavior, and we have deployment, different things we're going to do with that data once we get it. And these are just a list of the kinds of models we may want to build. So let me go through one kind of feature that has turned out to be tremendously productive for us. And that feature is this. When somebody comes to the website, it could be in store too, but let's do the website. What is most predictive? What kind of behavior describes Fred's behavior in the website? Is it clicks? Is it time on site? Those things are both helpful, but what's better is a measure of their engagement with the brand. What is their potential dollar spend during a session on the website? And this is showing Fred's 1, 2, 3, 4, 5, 6 visits on the website, and this is showing one of those visits where he interacted with 4 different products. One of those products was a rock star product, high dollar potential to the brand. Some were not so high. This we're calling his visit quality. So this is a feature to measure what the potential dollar spend of his visit was. Okay? But we know this too. Just because he didn't visit the day after doesn't mean he's no longer valuable. Right? Because he's got a memory. He knows what he did yesterday, and he's got something in his mind, some intent in his mind about what he intends to do. So that's why another good metric would be how engaged is he over time? And that engagement can be represented with something like this. We end up building an exponential decay where the decay rate is based upon site-wide traffic. So if it's around Black Friday and you don't come back tomorrow to the website, you decay a lot. That's a big deal. But if it's June, off-season, and you don't come for a week, maybe it's not such a big deal. Your decay is slower. And it's organically generated for every brand and every channel of interaction. So there are these different engagements from the sessions that Fred has, and this is his overall engagement. Okay, so if we do that, now we've got a bunch of different models. We have a brand level model. We can build models to describe what the quality of each of his visits was. And we can build models to describe what his engagement was day by day. So we know every day, no matter how many times he's interacted with the brand, we've got a score to measure his current engagement, but not just for the brand, at the brand level, but also the channel level and the instance level. Finish Line is one of our brands. They have 1,200 stores. That means there are 1,200 engagement scores, one for every store. There's an engagement score across all stores. There's an engagement score for the brand. For every way Fred interacts with the brand, we want to score them because we want to know. And we can build programs around each of those measures. That's where the big data is important because we couldn't do that 5 years ago. We can do that now in the cloud. And that lets us do things like this. So here's Kristen's 5 interactions with the brand. She first came in through an email. And this is her decay of that session with email. And then she came into a display ad. And then she came in direct. And then through a push, an SMS push, and then direct again. And based upon the decay scores, we can get at attribution, right? We can see what is the relative level at this point in time, what's the relative level of engagement, the proportion of engagement that comes from each of the channels where they began from. So you build the big data, everybody, every day, every point of interaction, and you can measure the relative importance of all those interactions, whether it's at the customer roll-up level, or at the marketing messaging roll-up level, or at the store level. You can measure engagement scores across the enterprise. It's important for different ways you might want to message your customers. Okay. So, in conclusion, I think we're about ready for it. Big data is great, but big data by itself isn't enough. We have to be smart about what we do with the big data. It can't just be throw the data into the hopper, stir the pot with the model, and out comes that perfect model to describe all the behaviors we're interested in. So we like to build features, build lots of them. Domain experts understand something about the problem. But remember, domain experts, Jim mentioned business analysts, and your business analysts are far better than the business analysts that I usually interact with because they actually do some SQL, they actually do some, maybe even some R. A lot of the business analysts I work with, they have no quant skills at all. They understand the business, but they can't even express what they want in quantitative terms. So there's a translation that always has to take place. But that's okay. If they can describe it clearly, we can interpret. And we can take those measures and turn them into quantitative representation. Cost-effective scaling computing enables predictive modeling. I didn't even mention things like the days to next purchase models we built. Predictive models to predict when they're going to purchase. Is it going to be in a week? Is it going to be in a month? Is it going to be in 3 months? And that depends on the brand. We have one brand that does consumables, like teas and coffees. And so when somebody buys something today, they're not going to buy again in 30 days or 60 days. And you can see that in the data. Their engagement is really high now, but their purchase propensity next week is really low. Their purchase propensity in a month is really high because they're buying on a regular cycle. Whereas another brand like Finish Line, if you're highly engaged now, you're poised to purchase tomorrow or in the next week. It's just a different way the customers interact with it. And last, remember the three-leg stool. Use the domain experts to your advantage. Build relationships with IT, because IT, oftentimes, I found IT often views me as the predictive modeler as an annoyance. Because I'm saying, can we build this? Can we build this? We don't have space for all that. Well, we need to build this big data market. So build those three relationships with that three-legged stool. I think at that, I'm going to have to close, and if we have time for questions, that's great. If we don't, you can talk to me afterwards. With one question, I guess. Yes.
Do you think deep learning could help with customer insights? Like, what are some use cases? Would it eliminate the need for extracting features?
So the question is, would deep learning help? Would you eliminate the need to build features with deep learning? I've been watching deep learning actually. I think you were there talking with Richard when I was there, asking him where deep learning may not do as well or where it does do well. I'll tell you my general philosophy of modeling algorithms. There's no algorithm that always wins. And we've seen it historically with competitions. Even now with competitions, deep learning networks don't always win competitions, even when they're always entering. Sometimes it's on some of the trees that will win. So I gave up a while ago betting on algorithms. I'm happy to use deep learning. I've not today, but I'm happy to try it and see how well it does. You're right that in some ways deep learning can overcome the feature extraction problem. Absolutely. But you still have to converge. You still have to converge that solution, and that may be problematic in itself. I don't know. My gut says that it's not the panacea. That if we just pour all resources into deep learning, all these problems are solved. It's really super quick. Yes.
Okay, never mind.
Okay, cool. Ask the question and then I'll answer it offline.
Okay. Yeah.
Okay, we'll talk offline. I guess at that we'll close up. Enjoy the rest of the conference and thank the organizers for coming to the conference.